Kīlauea. Kīlauea is an active shield volcano in the Hawaiian Islands, and the most active of the 5 volcanoes that together form the island of Hawaii. Located along the southern shore of the island, the volcano is between 210,000 and 280,000 years old and emerged above sea level about 100,000 years ago. It is the second youngest product of the Hawaiian hotspot and the current eruptive center of the Hawaiian Emperor Seamount chain. Because it lacks topographic prominence and its activities historically coincided with those of Mauna Loa, Kīlauea was once thought to be a satellite of its much larger neighbor. Structurally, Kīlauea has a large, fairly recently formed caldera at its summit and 2 active rift zones, one extending 125 km east and the other 35 km west, as an active fault of unknown depth moving vertically an average of 2 to 20 mm per year. Kīlauea erupted nearly continuously from 1983 to 2018, causing considerable property damage, including the destruction of the town of Kalapana in 1990, and the destruction of vacation land Hawaii in 2018. During the 2018 Lower Puna eruption, which began on May 3, 2 dozen lava vents erupted downrift from the summit in Puna. The eruption was accompanied by a strong earthquake on May 4 of MW 6.9, and nearly 2,000 residents were evacuated from the rural Leilani Estates subdivision and nearby areas. On May 17, 2018 at 4:17 a.m., the volcano explosively erupted at the summit in Hale Mau Mau crater, throwing ash 30,000 feet into the air. Continued explosive activity at the summit caused a months-long closure of the Kīlauea section of Hawaii Volcanoes National Park, while vigorous eruptive activity in Lower Puna sent lava into the ocean in 3 places, destroyed Hawaii's largest natural freshwater lake, covered substantial portions of Leilani Estates and Lani Puna Gardens, and completely inundated vacation land Hawaii and all but 3 houses in the Kapoho beach lots. Lava also filled Kapoho Bay and extended new land nearly a mile into the sea. The county of Hawaii reported that 716 dwellings were destroyed by lava. By early August the eruption subsided substantially, and the last active lava was reported at the surface on September 4, 2018. Portions of Hawaii Volcanoes National Park reopened to the public on September 22. On December 5, 2018, after 90 days of inactivity from the volcano, the eruption that started in 1983 was declared to be over. Kīlauea's eruptive history has been a long and active one. Its name means spewing or much spreading in the Hawaiian language, referring to its frequent outpouring of lava. The earliest lavas from the volcano date back to its submarine press-healed stage, samples having been recovered by remotely operated underwater vehicles from its submerged slopes. Samples of other flows have been recovered as core samples. Lavas younger than 1,000 years cover 90% of the volcano's surface. The oldest exposed lavas date back 2,800 years. The first well-documented eruption of Kīlauea occurred in 1823. Since then, the volcano has erupted repeatedly. Most historical eruptions occurred at the volcano's summit or its eastern rift zone, and were prolonged and effusive in character. The geological record shows, however, that violent explosive activity predating European contact was extremely common. In 1791 such eruption killed more than 400 people, making it the deadliest volcanic eruption in what is now the United States. Should explosive activity start anew, the volcano would become much more of a danger to humans. Kīlauea's current eruption dates back to January 3, 1983, and is by far its longest duration historical period of activity, as well as one of the longest duration eruptions in the world. As of January 2011, the eruption has produced 3.5 km3 of lava and resurfaced 123.2 km2 of land. Kīlauea's high state of activity has a major impact on its mountainside ecology, where plant growth is often interrupted by fresh tephra and drifting volcanic sulfur dioxide, producing acid rains particularly in a barren area south of its southwestern rift zone known as the Ka Desert. Nonetheless, wildlife flourishes where left undisturbed elsewhere on the volcano and is highly endemic thanks to Kīlauea's isolation from the nearest landmass. Historically, the 5 volcanoes on the island were considered sacred by the Hawaiian people, and in Hawaiian mythology Kīlauea's Hale Maumau crater served as the body and home of Pele, goddess of fire, lightning, wind, and volcanoes. William Ellis, a missionary from England, gave the first modern account of Kīlauea and spent 2 weeks traveling along the volcano. Since its foundation by Thomas Jagger in 1912, the Hawaiian Volcano Observatory, located on the rim of Kīlauea caldera, has served as the principal investigative and scientific body on the volcano and the island in general. In 1916, a bill forming the Hawaii Volcanoes National Park was signed into law by President Woodrow Wilson. Since then, the park has become a World Heritage Site and a major tourist destination, attracting roughly 2.6 million people annually. Like all Hawaiian volcanoes, Kīlauea was created as the Pacific tectonic plate moved over the Hawaiian hotspot in the Earth's underlying mantle. The Hawaii Island volcanoes are the most recent evidence of this process that, over 70 million years, has created the 6,000 km long Hawaiian Emperor Seamount chain. The prevailing, though not completely settled, view is that the hotspot has been largely stationary within the planet's mantle for much, if not all of the Cenozoic era. However, while the Hawaiian mantle plume is well understood and extensively studied, the nature of hotspots themselves remains fairly enigmatic. Kīlauea is one of 5 subaerial volcanoes that make up the island of Hawaii, created by the Hawaii hotspot. The oldest volcano on the island, Kohala, is more than 1 million years old, and Kīlauea, the youngest, is believed to be between 300,000 and 600,000 years of age. Hale Seamount, on the island's flank, is younger and has yet to breach the surface. Thus Kīlauea is the second youngest volcano in the Hawaiian Emperor Seamount chain, a chain of shield volcanoes and seamounts extending from Hawaii to the Kuril-Kamchatka Trench in Russia. Following the pattern of Hawaiian volcano formation, Kīlauea started as a submarine volcano, gradually building itself up through underwater eruptions of alkali basalt lava before emerging from the sea with a series of explosive eruptions about 50,000 to 100,000 years ago. Since then, the volcano's activity has likely been as it is now, a continual stream of effusive and explosive eruptions of roughly the same pattern as its activity in the last 200 or 300 years. At most 600,000 years old, Kīlauea is still quite young for a Hawaiian volcano. The oldest volcano on the island, the northwestern Kohala, experienced almost 900,000 years of activity before going extinct. The volcano's foreseeable future activity will likely be much like it has been for the past 50,000 to 100,000 years. Hawaiian and explosive activity will make Kīlauea taller, build up its rift zones, and fill and refill its summit caldera. Kīlauea has been active throughout its history. Since 1918, Kīlauea's only prolonged period of rest was an 18-year pause between 1934 and 1952. The bulk of Kīlauea consists of solidified lava flows, intermittent with scattered volcanic ash and tephra sourced from relatively lower volume explosive eruptions. Much of the volcano is covered in historical flows, and 90% of its surface dates from the last 1,100 years. Kīlauea built itself up from the seafloor over time, and thus much of its bulk remains underwater. Its subaerial surface is in the form of a gently sloping, elongate, decentralized shield with a surface area of approximately 1,500 km2, making up 13.7% of the island's total surface area. Kīlauea lacks a topographical prominence, appearing only as a bulge on the southeastern flank of the nearby Mauna Loa. Because of this, both native Hawaiians and early geologists considered it an active satellite of its more massive neighbor. However, analysis of the chemical composition of lavas from the 2 volcanoes shows that they have separate magma chambers, and are thus distinct. Nonetheless, their proximity has led to a historical trend in which high activity at one volcano roughly coincides with low activity at the other. When Kīlauea lay dormant between 1934 and 1952, Mauna Loa became active, and when the latter remained quiet from 1952 to 1974, the reverse was true. This is not always the case. The 1984 eruption of Mauna Loa started during an eruption at Kīlauea, but had no discernible effect on the ʻkiləʻweɪə eruption, and the ongoing inflation of Mauna Loa's summit, indicative of a future eruption, began the same day as new lava flows at ʻkiləʻweɪə's Pua crater. In 2002, Kīlauea experienced a high-volume effusive episode at the same time that Mauna Loa began inflating. This unexpected communication is evidence of crustal-level interactions between Mauna Loa and ʻkiləʻweɪə, even though these two volcanoes are thought to be fairly independent of each other. Geologists have suggested that pulses of magma entering Mauna Loa's deeper magma system may have increased pressure inside ʻkiləʻweɪə and triggered the concurrent eruptions. ʻkiləʻweɪə has a large summit caldera, measuring 4 by 3.2 km with walls up to 120 m high, breached by lava flows on the southwestern side. It is unknown if the caldera was always there or if it is a relatively recent feature, and it is possible that it has come and gone throughout ʻkiləʻweɪə's eruptive history. What is known is that the summit caldera likely formed over several centuries, with its construction estimated to have begun about 500 years ago, and its present form was finalized by a particularly powerful eruption in 1790. A major feature within the caldera is Hale crater, a large pit crater and one of ʻkiləʻweɪə's most historically active eruption centers. The crater is approximately 920 m in diameter and 85 m deep, but its form has varied widely through its eruptive history. The floor of the Hale crater is now mostly covered by flows from its 1974 eruption. ʻkiləʻweɪə has two rift zones radiating from its summit, one leading 125 km out to the east, the other 35 km long and trending towards the southwest. A series of fault scarps connecting the two rift zones form the Kauai fault zone. Tectonic extension along both rift zones is causing ʻkiləʻweɪə's bulk to slowly slide seaward off its southern flank at a rate of about 6 to 10 cm per year, centered on a basal décollement fault 7 to 9 km beneath the volcano's surface. The eastern rift zone in particular is a dominant feature on the volcano. It is almost entirely covered in lava erupted in the last 400 years, and at its crest near the summit is 2 to 4 km wide. Non-localized eruptions, typical of rift zone activity, have produced a series of low-lying ridges down the majority of the east rift zone's length. Its upper segment is the most presently active section of the volcano, and is additionally the site of a number of large pit craters. Its lower extremity reaches down ʻkiləʻweɪə's submerged flank to a depth of more than 5,000 m. By contrast, the much smaller southwestern rift has been quiet since a rifting episode in 1974, and to date, has not been involved in the current eruptive cycle at all. The southwestern rift zone's extremity is also underwater, although its submarine length is more limited. The southwestern rift zone also lacks a well-defined ridgeline or a large number of pit craters, evidence that it is also geologically less active than the eastern rift zone. A prominent structure on ʻkiləʻweɪə's southern flank is the Halina fault system, a highly active fault slipping vertically an average of 2 to 20 mm per year along the system. Its physiographic province is 500 m deep, but it is unknown whether it is a shallow listric fault or if it penetrates to the very base of the volcano. In connection with the 2018 Lower Puna eruption, the Hawaiian Volcano Observatory published some facts leading to the conclusion that a catastrophic collapse would be incredibly remote. A number of cinder cones, satellite shields, lava tubes, and other eruptive structures also dot the volcano, evidence of its recent activity. ʻkiləʻweɪə has some interactions with Mauna Loa, its larger neighbor and only other recently active volcano on the island. Interspersed lava flows and ash deposits belonging to its neighbor have been found on its flanks, and some of Mauna Loa's flows are, in turn, blanketed in ʻkiləʻweɪə tephra. In particular, the saddle between the two volcanoes is currently depressed, and is likely to fill over in the future. All historical eruptions at ʻkiləʻweɪə have occurred at one of three places: its summit caldera, its eastern rift zone, or its southwestern rift zone. Half of ʻkiləʻweىə's historical eruptions have occurred at or near ʻkiləʻweىə's summit caldera. Activity there was nearly continuous for much of the 19th century, capped by a massive explosive eruption in 1924, before petering out by 1934. Recent activity has mostly shifted to ʻkiləʻweىə's eastern rift zone, the site of 24 historical eruptions, located mostly on its upper section. By contrast, the volcano's southwestern rift zone has been relatively quiet, and has only been the site of 5 events to date. Geologists have dated and documented dozens of major eruptions over the volcano's long history, bridging the long gap between Kīlauea's oldest known rock and only extremely recent written records and historical observation. Historical lava flows from the volcano are generally recovered by scientists in one of 3 ways. The oldest flows, dating back 275,000 to 225,000 years, have been recovered from Kīlauea's submerged southern slope by ship-towed remotely operated vehicles. These lavas exhibit forms characteristic of early, submerged preshield stage eruptive episodes, from when the volcano was still a rising seamount that had not yet breached the ocean surface, and their surface exposure is unusual, as in most other volcanoes such lavas would have since been buried by more recent flows. The second method of recovering older rock is through the drilling of deep core samples. However, the cores have proved difficult to date, and several samples from depths of around 1,700 m that suggested dates as old as 450,000 years have since been found erroneous. More reliable paleomagnetic dating, limited to rocks dating from after Kīlauea's emergence from the sea, has suggested ages of around 50,000 years. Exposed flows above sea level have proved far younger. Some of the oldest reliably dated rock, 43,000 years old, comes from charcoal sandwiched beneath an ash layer on a fault scarp known as Halina. However, samples dated from higher up the scarp indicate ash deposition at an average rate of 6 m per thousand years, indicating that the oldest exposed flows, from the base of the feature, could date back as far as 70,000 years. This date is similar to that of the oldest dated extant lava flow, a southwestern rift zone flow with an uncorrected radiocarbon dating of approximately 4,650 BC. The oldest well-studied eruptive product from Kīlauea is the ʻkahuna ash member, the product of explosive eruptions between 2,800 and 2,100 years ago. Although it has since been largely buried by younger flows, it remains exposed in some places, and has been traced more than 20 km from the volcano's caldera, evidence of very powerful eruptions. Evidence suggests the existence of an active eruptive center at this time, termed the Powers Caldera, 2 km away from the modern one. At least 1,200 years ago, lava from the Powers Caldera overtopped its rim and solidified the structure. This was followed by a period of very voluminous tube-fed foʻiʻoe flows from the summit. Following cessation of activity around 400 years ago, eruptions recentered on the eastern part of Kīlauea's summit, and concurrently activity increased at the northern end of the eastern rift zone. The earliest reliable written records of historical activity date back to about 1820, and the first well-documented eruption occurred in 1823, when the volcano was first put under observation. Although native Hawaiians are thought to have first settled on the island around 1,500 years ago, oral records predating European arrival on the island are few and difficult to interpret. One pre-contact eruption in particular, a phreatomagmatic event in 1790, was responsible for the death of a party of warriors, part of the army of Kīlauea, the last island chief to resist Kamehameha's rule. Their death is evidenced by a set of footprints preserved within the Hawaii Volcanoes National Park, which are listed on the National Register of Historic Places. Kīlauea has been the site of 61 separate eruptions since 1823, easily making it one of the most active volcanoes on Earth. During its observed history, the volume of lava erupted by Kīlauea has varied widely. In 1823, Kīlauea's summit caldera was far deeper than it is today, but was in the process of filling up under nearly continuous summit eruption, with 3 km of lava erupted there alone by 1840. The period between 1840 and 1920 saw approximately half that in eruptive volume, and in the 30 years between then and about 1950, the volcano was unusually quiet and exhibited very little activity. Kīlauea's eruptive volume has increased steadily since then, with present activity comparable to that of the early 1800s. The length and origin of these eruptions have also varied. Events last anywhere between days and years, and occur at a number of different sites. Half of all eruptions occur at or near Kīlauea's summit caldera. Activity there was nearly continuous for much of the 19th century, and after a reprieve between 1894 and 1907, continued onwards until 1924. There have been 5 historical eruptions at the volcano's relatively quiet southwestern rift zone, and 24 along its more active eastern rift zone, mostly along its upper section. The volcano's observed history has mostly been one of effusive eruptions, however, this is a relatively recent occurrence. Prior to the arrival of the first Europeans on the island, Kīlauea was the site of regular explosive activity, evidenced then by tribal chants referencing the volcano's fickle nature, and today by geological records of an explosively active mode of past activity. Although explosive activity still occurs at the volcano, it is not as intense as it once was, and the volcano would become much more dangerous to the general public if it returned to its old phase of activity once more. Kīlauea erupted in 1823 and 1832, but the first major eruption since the 1790 event occurred in 1840, when its eastern rift zone became the site of a large, effusive Hawaiian eruption over 35 km of its length, unusually long even for a rift eruption. The eruption lasted for 26 days and produced an estimated 205 to 265 million cubic meters of lava. The light created by the event was so intense that one could reportedly read a newspaper in Hilo at night, 30 km away. The volcano was active again in 1868, 1877, 1884, 1885, 1894, and 1918, before its next major eruption in 1918–1919. Hale Maumau, then a small upwelling in the caldera floor, was topped by a lava lake that then drained, before refilling again, forming an enormous lava lake and nearly reaching the top edge of the caldera before draining once more. This activity eventually gave way to the construction of Mauna Loa, building up the large lava shield within the caldera over a period of 8 months. The eruption also featured concurrent rift activity and a large amount of lava fountaining. Activity in 1921–1923 followed. The next major eruption occurred in 1924. Hale Maumau crater, a fully formed pit crater after the 1919 event and the site of a sizable lava lake, first drained, then quickly began sinking into the ground, deepening to nearly 210 m beneath a thick cloud of volcanic ash. Explosive activity began on May 10 of that year, blowing rock chunks weighing as much as 45 kg 60 m out, and smaller fragments weighing about 9 kg out as far as 270 m, and, after a brief reprieve, intensified through a major blast on May 18, when an enormous explosive event caused the eruption's only fatality. The eruption continued and formed numerous eruption columns up to and beyond 9 km in height, before slowly petering down and ending by May 28. Volcanic activity was soon confined to the summit, and ceased completely after 1934. After the Hale Maumau event, Kīlauea remained relatively quiet, and for a time, completely silent, with all activity confined to the summit. The volcano came alive again in 1952, with an enormous lava fountain 245 m high at the Hale Maumau crater. Multiple continuous lava fountains between 15 and 30 m persisted, and the eruption lasted 136 days. Eruptions occurred soon after in 1954, 1955, and 1959, capped by a large event in 1960, when fissure-based phreatic eruption and earthquake activity gave way to a massive with macron flow that overran multiple evacuated communities and resorts. The resulting summit deflation eventually caused the ever-active Hale Maumau to collapse even further. Following the event, eruptive events yearly and nearly continuous, a state of activity that remains today. The period 1967–1968 saw a particularly large, 80 million cubic meter, 251-day event from Hale Maumau crater. This event was superseded the very next year by the Marathon Mauna Loa eruption, a large effusive eruption which lasted from May 24, 1969 to July 24, 1974 and added 230 acres of new land to the island. After eruptive activity had died down, there was a magnitude 7.2 earthquake that caused a partial summit collapse, after which activity did not resume at Kīlauea until 1977. At the time, Mauna Loa was the longest flank eruption of any Hawaiian volcano in recorded history. The eruption created a new vent, covered a large area of land with lava, and added new land to the island. The eruption started as a fissure between two pit craters, Loi and Hale, where the Mauna Loa shield would eventually form. Both Fo'ioi and Aa with Macron lava erupted from the volcano. Early on, fountains of lava burst out as much as 540 meters high. In early 1973, an earthquake occurred that caused Kīlauea to briefly stop erupting near the original Mauna Loa site and instead erupt near the craters Pauahi and Haiaka. The most recent major eruption at Kīlauea has been the longest duration of any observed eruption. The current Kīlauea eruption began on January 3, 1983, along the eastern rift zone. The vent produced vigorous lava fountains that quickly built up into the Pio cone, sending lava flows down the volcano's slope. In 1986, activity shifted down the rift to a new vent, named Kīlauea, where it took on a more effusive character. Kīlauea built up a low, broad volcanic shield, and lava tubes fed flows extending 11 to 12 km to the sea. Between 1986 and 1991, the connection between Chain of Craters Road and Hawaii Route 130 was cut, and the community of Kapa'ahu, the village of Kalapana, and the subdivisions of Klapana Gardens and Royal Gardens were lost to the lava. A black sand beach at Kime was also engulfed. In 1992, the eruption moved back to Pio, but continued in the same manner, covering nearly all of the 1983-86 lava flows and large areas of coastline. As of the end of 2016, the East Rift Zone eruption had produced 4.4 km3 of lava, covered 144 km2 of land, added 179 ha of land to the island, destroyed 215 structures, and buried 14.3 km of highway under lava as thick as 35 m. In addition to the nearly continuous activity at Pu'o and other vents on the East Rift Zone, a separate eruption began at Kilauea's summit in March 2008. On March 19, 2008, following several months of increased sulfur dioxide emissions and seismic tremor, a new vent opened at Hale Maumau crater at Kilauea's summit in an explosive eruption. Following this event, the new crater formed in the explosion, informally named the Overlook crater, emitted a thick gas plume that obscured views into the vent. Several other explosive events occurred at the vent throughout 2008. On September 5, 2008, scientists observed a lava pond deep within the Overlook crater for the first time. Beginning in February 2010, a lava pond was visible at the bottom of the crater almost continuously through the beginning of May 2018. Lava briefly overflowed the vent onto the floor of Hale Maumau crater in April and May 2015, October 2016, and April 2018. Beginning in March 2018, Hawaiian Volcano Observatory began to detect rapid inflation at PUU, leading scientists to warn that the increased pressure could lead to the formation of a new vent at Kīlauea. Following weeks of increased pressure, the crater floor of the cone of Pio collapsed on April 30, 2018, as magma migrated underground into the lower Puna region of Kilauea's lower East Rift Zone. Over the next few days, hundreds of small earthquakes were detected on Kilauea's East Rift Zone, leading officials to issue evacuation warnings. On May 3, 2018, new fissures formed, and lava began erupting in Lower Puna after a 5.0 earthquake earlier in the day, causing evacuations of the Leilani Estates and Lani Puna Gardens subdivisions. A seemingly related 6.9 magnitude earthquake occurred on May 4. By May 9, 27 houses had been destroyed in Leilani Estates. By May 21, 2 lava flows had reached the Pacific Ocean, creating thick clouds of laze, which is made up of hydrochloric acid and glass particles. By May 31, 87 houses in Leilani estates and nearby areas had been destroyed by lava. Advancing lava flows caused additional evacuation orders, including the town of Kapoho. By June 4, with the lava having crossed through Kapoho and entered the ocean, the confirmed number of houses lost had reached 159. 2 weeks later, the confirmed number of homes lost was 533, and as of June 25 it had risen to 657. Together with the outbreak of lava in Lower Puna, a lava lake at Hale Maumau crater at Kīlauea's summit began to drop on May 2, 2018. The Hawaiian Volcano Observatory warned that the lowering of the lava lake increased the potential for phreatic explosions at the summit caused by interaction of magma with the underground water table, similar to the explosions that occurred at Hale Maumau in 1924. These concerns prompted the closure of Hawaii Volcanoes National Park. On May 17, at approximately 4:15 a.m., an explosive eruption occurred at Hale Maumau, creating a plume of ash 30,000 feet into the air. This marked the beginning of a series of vigorous explosions that have produced significant ash plumes from Hale Maumau. These explosions, accompanied by large earthquakes and inward slumping and collapse within and around Hale Maumau crater, continued until early August. In 2018, the United States Geological Survey National Volcanic Threat Assessment gave Kīlauea an overall threat score of 263, and ranked it first among volcanoes in the United States most likely to threaten lives and infrastructure. The Global Volcanism Program has assigned a volcanic explosivity index to all except 5 of Kīlauea's 95 known eruptions of the last 11,700 years. The eruption of 1790 has a VE of 4. The 1983-2018 eruption has a VE of 3. The eruptions of 1820, 1924, 1959, and 1960 have a VE of 2. The eruptions of 680, 1050, 1490, 1500, 1610, 1868 and 4 eruptions in 1961 have a VE of 1. The other 74 eruptions have a VE of 0. Because of its position more than 3,000 kilometers from the nearest continental landmass, the island of Hawaii is one of the most geographically isolated landmasses on Earth. This in turn has strongly influenced its ecology. The majority of the species present on the island are endemic to it and can be found nowhere else on Earth, the result of an isolated evolutionary lineage sheltered from external biotic influence. This makes its ecosystem vulnerable both to invasive species and human development, and an estimated third of the island's natural flora and fauna has already gone extinct. Kīlauea's ecological community is additionally threatened by the activity of the volcano itself. Lava flows often overrun sections of the volcano's forests and burn them down, and volcanic ash distributed by explosive eruptions often smothers local plant life. Layers of carbonized organic material at the bottom of Kīlauea ash deposits are evidence of the many times the volcano has wrought destruction on its own ecosystem and that of its neighbor Mauna Loa, and parts of the volcano present a dichotomy between pristine montane forest and recently buried volcanic deserts yet to be recolonized. Kīlauea's bulk affects local climate conditions through the influence of trade winds coming predominantly from the northeast, which, when squeezed upwards by the volcano's height, result in a moister windward side and a comparatively arid leeward flank. The volcano's ecology is further complicated by height, though not nearly as much as with its other, far taller neighbors, and by the local distribution of volcanic products, making for varied soil conditions. The northern part of Kīlauea is mostly below 1000 m and receives more than 75 in mean annual rainfall, and can mostly be classified as a lowland wet community. Farther south, the volcano has squeezed out much of the precipitation and receives less than 50 in mean annual rainfall, and is considered mostly a lowland dry environment. Much of Kīlauea's southern ecosystem lies within the Hawaii Volcanoes National Park, where ae ferns, haya trees, and hapu'u of the genus Sebotium are common. The